Webb just made the sharpest map of dark matter ever built, and I want to explain exactly what that means, because it's more impressive than it sounds. Let me start with the basic fact. In January 2026, a team published a paper in Nature Astronomy. They used the James Webb Space Telescope to map where dark matter sits across a large patch of sky. That patch is roughly 2.5 times the size of a full moon. The map they produced is twice as sharp as anything built before. And to me, that number, twice as sharp, only starts to feel real once you understand what dark matter mapping actually is. So first, let me explain what dark matter even is, because this is where a lot of people get lost. Dark matter is not a gas. It is not a cloud. It is not anything we have ever touched or seen directly. It emits no light. It absorbs no light. Every tool we have ever built to detect the universe, telescopes, radio dishes, X-ray sensors, none of them can see dark matter directly. It is completely invisible by every measure we have. But here is the thing. The current theory says dark matter has mass, and mass has gravity, and gravity bends light. So even though we cannot see dark matter itself, we can see what it does to the light passing near it. That is the entire basis of how this map was made. The method is called gravitational lensing. I find this genuinely fascinating. When light from a distant galaxy travels toward us, if there is a massive object between us and that galaxy, even an invisible one, the gravity from that object bends the light. It warps it. It stretches it. The distant galaxy appears slightly distorted. Sometimes it appears as an arc, sometimes as a ring, sometimes just slightly elongated in one direction. By measuring how much distant galaxies are distorted, scientists can work backwards and figure out where the mass is that bent the light. That mass is dark matter. And here is a number that still gets me every time I think about it. The current confirmed data says dark matter makes up roughly 27% of everything in the universe. Ordinary matter, every star, planet, gas cloud, person, atom you have ever encountered, that makes up only about 5%. Dark matter is more than 5 times as abundant as everything we can actually see. And we have never directly detected it once. Now let me explain what the map actually shows. The region they mapped is part of a survey called Cosmos. It has been studied for years. The first dark matter map of this region was made with the Hubble Space Telescope back in 2007. That Hubble map was already a big deal at the time. It showed the rough distribution of dark matter, where it clumped, where it spread out, how it formed a kind of invisible web or scaffolding that the visible universe seems to sit inside of. But Hubble had limits. The map was blurry by comparison. It showed the large-scale structure, but missed the finer details. The way I think about it is like the difference between a low-resolution satellite photo of a city and a high-resolution one. The low-res version shows you where the city is. The high-res version shows you the streets, the buildings, the gaps between them. Webb is the high-res version. The new 2026 map is twice as sharp as any previous map of the same region. That means structures in dark matter that Hubble simply could not resolve are now visible. And this is where the "something strange" part of the headline comes in. Some dark matter structures in the Webb data look smaller than they did in the Hubble data. And the first instinct is to ask, did the dark matter change? Did something happen to it? But the answer is more interesting and also more straightforward. The structures are not actually smaller. They just look smaller now because we can finally see their true edges. When the image was blurry, the boundaries of these structures blurred outward. They looked bigger than they really were. Now that the image is sharper, those same structures have cleaner boundaries. They appear more compact, not because they shrank, but because we can now see where they actually stop. I find that fascinating. It means our older maps were not wrong exactly. They just lacked the precision to show us the true shape of things. It is like looking at a fuzzy photo of a rock formation and thinking it is one big blob, then getting a sharp photo and seeing it is actually 3 separate rocks close together. What the Webb map shows more clearly than ever is what scientists call the cosmic web. This is the confirmed large-scale structure of the universe. Dark matter does not spread out evenly. It forms long strands, called filaments, with huge empty voids between them. At the intersections of those filaments, where the most dark matter piles up, you find galaxy clusters. The visible universe, all the stars and galaxies, tends to sit right inside and along those dark matter filaments. Ordinary matter falls into the gravitational wells that dark matter creates. The way I understand it, dark matter built the scaffolding first. Gravity pulled it into filaments and clusters over billions of years. Then ordinary matter, gas, dust, eventually stars, fell into those structures and formed the galaxies we see. Without dark matter, current theory says galaxies would not have formed the way they did. The universe might have been a much more uniform, much emptier place. Now, the Webb map does not tell us what dark matter is made of. I want to be clear about that. We still do not know. That is one of the biggest open questions in all of physics right now. There are multiple competing ideas. The most popular candidate for years was something called a WIMP, a weakly interacting massive particle. The idea was that dark matter consists of particles that have mass and feel gravity but barely interact with ordinary matter at all. Experiments have been searching for WIMPs for decades. Underground detectors, particle colliders, space-based observations. So far, nothing confirmed. No WIMP has ever been detected. Another idea is axions. These are a different kind of theoretical particle, extremely light, extremely numerous. Some experiments are looking for axions specifically. Again, no confirmed detection yet. Some scientists suggest it might not be particles at all. There are theories involving primordial black holes. Black holes formed in the very early universe before any stars existed. These would be invisible and massive and spread throughout space. Some data hints this might be part of the answer, but it is still speculation. No confirmation yet. What I find striking about this is that we have mapped where dark matter is more clearly than ever, but we still have zero confirmed idea of what it actually is. We know its shape before we know its substance. That is genuinely strange when you think about it. And the new Webb map helps with the shape part more than anything before it. The map covers a large area and shows fine detail simultaneously. That combination is hard to achieve. Normally in astronomy, you trade one for the other. A wide view has low detail. A detailed view has a narrow field. Webb managed both here because of its engineering. Its infrared sensitivity and large mirror let it detect very faint, very distant, very slightly distorted galaxies across a wide field at once. To make the dark matter map, the team analyzed the shapes of a huge number of background galaxies. Each galaxy's distortion is very small. We are talking about tiny, subtle stretches in shape. You cannot trust the measurement from a single galaxy because galaxies naturally come in all kinds of shapes. But when you look at hundreds of thousands of galaxies together, the random natural variations average out. What is left is a shared pattern, a consistent distortion that can only come from mass bending the light. That shared pattern tells you where the dark matter is. The confirmed result is the map published in Nature Astronomy. The sharpest, largest dark matter map ever made with Webb. It covers the cosmos field. It resolves structures that Hubble could not. And it adds a new layer of detail to our understanding of how matter, visible and invisible, is distributed across the universe. What I think is important here is what this map enables going forward. Dark matter mapping like this is how scientists test theories about how the universe formed and evolved. If a theory predicts dark matter should be distributed in a certain way, and the map shows something different, that theory needs adjusting. The sharper the map, the more precisely we can test those predictions. Webb's map raises the bar for every future test of every theory about cosmic structure. It also opens the door to finding things that were hidden before. Now that we can see finer structure in dark matter's distribution, there may be features in that structure that tell us something about what dark matter actually is, what its properties are, how it behaves at small scales, whether it acts exactly like the standard models predict, or whether something is off. Those kinds of subtle differences might eventually point toward an answer. So for me, the main thing is this. We cannot see dark matter. We have never touched it. We do not know what it is made of, but we can see what it does to light. And Webb just gave us the clearest picture of that effect we have ever had. We mapped the invisible scaffolding of the universe, not with guesswork, but with confirmed physics and the most powerful space telescope ever built. That is important, not because it solved the mystery of dark matter, but because it gave us a much sharper map to search inside.